Okay, so good evening everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor Hampeyo Kliman. And if you are new to this channel, consider subscribing, hitting the like button, and don't forget to share. And of course, if you have not yet registered for personal tuitions, ensure that you register or you inbox me on this particular WhatsApp number. Okay, so it's a plus 26077 66 40 46. So this is the WhatsApp number that you are supposed to inbox me if you want to register for personal tuitions. Okay, so I bring you yet another tutorial on set laws. Okay, set laws are very important. If you understand them, you will be able to solve particularly most of the questions under sets. Okay, so they are what we call laws of sets. Okay, they are what we call laws of sets in algebra, and we are going to go through each one of them for you to understand. The first law, sir, to be specific, is called the Idempotent. So the first law is called the Idempotent. Okay, so it's called the Idempotent. This is the Idempotent law. What does this law state? This law states that if, for example, you have set A, and this set A is uniting with itself, then your answer is going to be that set. Okay, so this is what this law states. So the union of a set by itself produces that set. A very good example, if you've got set A and this is the set, and you've been told to find A, the union of set A, notice that when you unite A and A, what you're going to have is simply the same set. Henceforth, this law states that the union of a set by itself is going to produce that set. Okay, that is what this particular law states. The second law is called the identity law. The identity law. What does this law state? This law simply states that if you've got an empty set and that empty set is being united with a particular set which we can give as an example B, then the answer that you're going to find is simply that particular set B. So the union of an empty set with a set B is going to give you a set B. Okay? At the same time, if this is a set B and you are intersecting set B with the empty set, okay, the intersection of B with the empty set is going to give you the empty set. Okay, to give you an example, if B is a set of elements 1, 2, 3, and C is the empty set, okay, and C is the empty set, then what you are, then if you find the intersection, okay, if you find the intersection of B and C, you discover that they are not intersecting anywhere. Henceforth, that gives you the empty set. That is a very important law for you to recognize. Okay? That is a very important law for you to recognize. Okay. Another thing that you must understand, the union of a set with the universal set gives you the universal set. So if B is a set and you unite B, or you find the union of set B with the universal set, then what you're going to find is the universal set. Why? Because let's say the universal set is the set from 0, 1, 2, 3, 4, and B is a set from 1, 2, 4. If we are to find B union of the universal set, we are just going to have the entire universal set, because union is just a combination of all sets. Okay? Henceforth, this particular law holds. It's very important for you to understand. Okay? It's very important for you to understand that particular law. Another thing that I would want you to understand is this. Under this law, the intersection of a particular set with a universal set is going to give you that set. Okay? Remember, we said that if B is uniting with the universal set, it will give you the universal set. But if B is intersecting with the union set, then definitely it will give you the set B itself. Why? Because if we are to find the intersection of B intersection the union set, then what is common is this and that, this and that, this and that. Henceforth, we are going to get 1, 2, and 4, which is just the set B itself. Henceforth, this particular system holds. It's very important for you to understand that law. The third law, which I am going to teach you, is called the commutative law. Commutative law. Commutative law. What does the commutative law state? The commutative law simply states that if you've got a set A and this set A is uniting with set B, then this can also be written in the order B uniting with set A. The essence of this law is simply to tell you that the order or arrangement of sets, doesn't matter. Okay? At the same time, if this is my set A intersecting with set B, this can also be written as B intersecting with set A. The order doesn't matter. All right, we come to the fourth law, which is simply the associative law. To associate, to link up. What does this law state? If you've got the open bracket of some union of set B, then the union of set C, this can also be written as some set A uniting with the open bracket of some B, the union of set C. This law implies that the order or grouping of sets, the order or grouping of sets doesn't matter. At the same time, if you've got a set, which set can I give as an example? Okay, if you've got a set A intersecting some set B, the intersection of C, then this can also be written as A intersection the open bracket of B intersecting with C. Okay, so the order or grouping of sets in this case, it doesn't matter. So make sure that you understand these simple concepts I'm teaching. They are very important to understand. We'll go to the fifth one. Complement laws. Complement laws. Now, for complement laws, which are very important in this case, if you've got a set A and that set is uniting with the complement of itself, then what you're going to get is the universal set. Okay? A uniting with the complement of itself is you're going to get the universal set. Okay, so if I was to give an example for this particular set, if this is my universal set, and this universal set comprises of 0, 1, 2, 3, 4, 5, and a 6, and this is my set A, and set A is a set of 1, 3, and 4, okay? If I was to find A uniting with A complement, okay? Complement simply means outside of. So when I say A complement, I'm simply telling you get whatsoever, okay? Get every element that is going to remain if you remove all the elements in A. So in this case, if we remove 1, 3, and 4, we remove 1, 3, and 4. What we remain with is with 0, a 2, a 5, and a 6. In other words, what we are going to remain with are numbers in the universal set. That is what that law implies. Okay? It's very important for you to understand. How about if it's in this order? How about if you have a set A intersecting with a complement of itself? What do you get? Okay, if this is set A, 1, 3, and 4, and this is the universal set, and we've been asked to find A intersecting A complement, okay, A intersecting A complement. Remember I said complement means outside of, so the complement of A simply means all the numbers that are outside A. Get all the numbers outside of set A. Now, all the numbers outside of set A are simply 0, okay, 0, 2, 5, and 6, okay? Then they tell you to find the intersection. So set A is this set. And the complement of A is this set. Then if we find the intersection of this particular set with this set, we will find that they're not intersecting anywhere, henceforth they give us the empty set. That is how we are coming up with that particular operation. Another operation which I want you to understand is this. How about if you've got a, the complement of a to the power of the complement? What are you going to get? Well, if you've got a complement in brackets being powered to a complement, then what you are going to get is the set itself. So in this case, just cancel the complements and get your final answer as your set A. Okay? D. How about the complement? How about if you find if you've been asked to find the complement of the universal set? How do you find the complement of the universal set? Complement of the universal set, they are simply telling you, remember I said complement means outside of. So when they say complement of the universal set, they're telling you all the numbers in the universal set, now get whatsoever is remaining. So the universal set comprises of everything, of all the numbers. All the numbers. So if we remove all these numbers, what are we going to remain with? We will remain with nothing. Henceforth, we'll remain with the empty set. How about if you've been asked to find the complement of an empty set? The complement of an empty set. Complement of an empty set means in that empty set, get whatsoever is going to remain. So if you get an empty set, if this is C and it is an empty set, and we've been told that this is a complement, meaning we are going to get everything that is going to remain if we remove the empty set. So in this case, we will remain with all the members in the universal set. Correct? So henceforth, the complement of an empty set gives you the universal set. That is very important for you to understand. We go to a final law. We go to a final law, which we are simply calling as the De Morgan's law. The De Morgan's law. Okay. The De Morgan's law simply states that if you have the open bracket of some set A uniting with B complement, then what you are going to get should be equivalent to A complement exposed to the union set, to the union symbol becomes the intersection set. Complement exposed to B becomes the complement B. That is what De Morgan's law states. At the same time, if you have the open bracket of some set A intersecting with B complement, De Morgan's law simply states that this complement exposed to this set A becomes A complement, and this complement exposed to the intersection becomes the union set, and this complement exposed to B eventually becomes B complement. That is what De Morgan's law simply states. How about if you've been asked to prove De Morgan's law? How do you prove De Morgan's law? How do you prove De Morgan's law? Proving De Morgan's law is actually very simple. Okay? It's actually very simple. We are going to go through it. Let me give an example. An example that I'm going to give is going to be this. If this is the universal set and it comprises of figures from 1, 2, 3, 4, 5, 6, and then we've got this set A, and set A is a set of 1 to 2, and then we have set B, which is a set of 2, 3, we've been asked to perform this particular operation. Prove, okay, this is the question. Prove that A union B complement is the same as A complement intersection B complement. Now, to answer this particular question, it's very simple if you understand what I'm going to do. We are going to start, this is going to be my left hand side. This is going to be my right, that is going to be right hand side. Right hand side. Right hand side. So I'm going to start with my left hand side. Let me prove my left hand side. So in the left hand side, okay, in the left hand side we have the open bracket of A union B complement. So let me start first of all by working out what is inside. A union B is this set. We are uniting A and B, so it's going to be 1, yes, 2, and 3. That is A union B. Okay. Now we have been taught that we now find A union B complement. Complement simply means outside of. So all the numbers that are going to remain if we remove this particular set. So in this case, it is simply the universal set minus 1, 2, 3. That is how you remember the complement, the easiest way. In this case, we are removing 1, 2, 3 from the universal set. We are removing 1, 2, 3. We are going to remain with a 4, a 5, and a 6. This is what we have on the left hand side. Let's see what we're going to have on the right hand side. Right hand side, we have A complement intersection B complement. So in this case, let's find A complement. A complement is A complement means remove everything in A, whatever you're going to remain with in the universal, that becomes the answer. So A, we are removing 1 and 2, and what we are going to remain with is a 3, a 4, a 5, and a 6. How about if we find B complement? B complement, we are removing if we remove 2 and 3, whatever we're going to remain with in the universal, that is the answer. So 2 and 3 are out. We are going to remain with 1, then 4, then 5, then 6. Then we find the intersection of A complement intersection B complement. Well, what is found in B complement and A complement? It's a 4, it's a 4, yes. It's a 5, it's a 5, yes. It's a 6, it's a 6. So we are getting 4, 5, and 6. Henceforth, what is on the right is the same with what is on the left. Henceforth, that is exactly how you prove De Morgan's law. Okay, that is quite very simple to understand. Quite very simple. Let's do an example 2. How about if you've been given the universal set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you've got a set of 1, 2, 3, 4, 5. Then your B is a set of 2, 4, 6, 8, and a 10. And your set C is a set of 1, 3, 5, 7, and a 9. Then you've been asked to prove A union B union C complement. Prove that it is equal to A complement intersection B complement intersection C complement. So let's prove. Same concept. This is my left hand side. This is my right hand side. Regardless how it looks complicated, it is actually very simple. So let's now work out what is inside. So we are going to find A union B union C. Let's find the union of all these. So we have a 1 in A. Okay, that is going to be a 1. That is going to be a 2. That is going to be a 3, a 4, a 5. Then we are going to have, okay, we have a 6 there. We have a 7. We have a 8. We have a 9. We have a 10. Cool. Okay. Then we have been taught that we now remember complement means everything outside of. So everything outside of this. What numbers are we going to remain with if we remove this? Well, we are remaining with the empty set, because this is what we have in the universal set. So remaining the empty set. Let's work out what is on the right hand side now. Right hand side, we've got A complement intersection B complement intersection C complement. So let's do A complement. A complement. A complement. We are removing 1, 2, 3, 4, 5. So it will include all numbers from 6, 7, 8, 9, 10. Then B complement is going to be a set. It's going to be a set. Let me see. So we are removing 2. We're removing 2. We're removing 2, 4, 6, 8, and a 10. So we are going to remain with 1, 3, 5, 7. That is a 9. Yes. Then C complement. What are we remaining with? C, we're removing a 1, a 3, a 5, a 7, and a 9. So we're going to remain with a 2, a 4, a 6, 8, and a 10. Then we have been told that we find the intersection of these numbers. So the intersection of A complement, intersection B complement, intersection C complement, where are they intersecting? We've got a 6. We've got a 6. There is no 6 in this figure, in this set. We've got a 7. We've got a 7. There is no 7 in here. We've got 8. We've got 8. There is no 8 in here. We've got a 9. We've got a 9. Yes, there is no 9 in here. We've got a 10. We've got a 10, but there is no 10 in this set. Henceforth, they are not intersecting at any point. That gives us the empty set. Henceforth, right hand side is equal to left hand side. That is just how you prove De Morgan's law. If you found this video interesting, consider subscribing, hitting the like button, and don't forget to share to others. Above all, don't you forget to join the Hampel Kleeman Online Academy and learn with us from the best on Google Meet. Thank you so much.